Welcome to the world of software engineering. In this video, we will take you through the basics of software engineering, including its definition, importance, and the skills required to become a software engineer. Software engineering is the process of designing, developing, testing, and maintaining software. It involves the application of engineering principles to software development, with the aim of creating high-quality, reliable, and efficient software systems. Software engineering is an essential field in today's digital age, as software is used in almost every aspect of our lives, from mobile apps to web applications, from video games to medical devices. Software engineers play a crucial role in creating these software systems, ensuring that they are functional, secure, and user-friendly. To become a software engineer, you need to have a strong foundation in computer science, mathematics, and programming. You should also possess problem-solving skills, attention to detail, and the ability to work in a team. In the next segment, we will discuss the software development lifecycle, which is the process of creating software from conception to deployment. The software development lifecycle (SDLC) is the process of creating software from conception to deployment. It consists of several phases, each with its own set of activities and deliverables. The first phase of the SDLC is the planning phase. In this phase, the software requirements are gathered, analyzed, and documented. The project scope, timeline, and budget are also defined in this phase. The second phase is the design phase. In this phase, the software architecture is designed and the software components are identified. The design phase also includes creating a detailed design document that outlines the software's functionality, user interface, and data structures. The third phase is the development phase. In this phase, the software is developed according to the design specifications. The software code is written, tested, and debugged. The development phase also includes creating user manuals and training materials. The fourth phase is the testing phase. In this phase, the software is tested to ensure that it meets the requirements and is free of defects. The testing phase includes unit testing, integration testing, system testing, and acceptance testing. The final phase is the deployment phase. In this phase, the software is deployed to the production environment. The deployment phase includes installation, configuration, and training. The SDLC is an iterative process, meaning that each phase may be revisited and revised as needed. The SDLC is a critical process in software engineering, as it ensures that the software is developed according to the requirements and is of high quality. In the next segment, we will discuss programming languages, which are the tools used to write software code. Programming languages are the tools used to write software code. There are many programming languages available, each with its own syntax, rules, and features. Some of the most popular programming languages include Java, Python, C++, JavaScript, and Ruby. Each programming language has its own strengths and weaknesses, and the choice of programming language depends on the requirements of the software project. Java is a popular programming language used for developing enterprise-level applications. It is known for its platform independence, meaning that Java code can run on any platform that has a Java Virtual Machine (JVM) installed. Python is a higher-level programming language used for developing web applications, scientific computing, and data analysis. It is known for its simplicity and ease of use. C++ is a powerful programming language used for developing system software, such as operating systems and device drivers. It is known for its speed and efficiency. JavaScript is a scripting language used for developing web applications. It is known for its ability to create dynamic and interactive web pages. Ruby is a dynamic programming language used for developing web applications and scripting. It is known for its simplicity and productivity. In addition to these programming languages, there are also many frameworks and libraries available that make software development easier and more efficient. Some popular frameworks include React, Angular, and Django. In the next segment, we will discuss software testing, which is a critical aspect of software engineering. Software testing is a critical aspect of software engineering. It is the process of evaluating software to ensure that it meets the requirements and is free of defect. There are several types of software testing, including unit testing, integration testing, system testing, and acceptance testing. Unit testing is the process of testing individual software components, such as functions or methods, to ensure that they work as expected. Unit testing is usually automated and is performed by developers. Integration testing is the process of testing how different software components work together. Integration testing is usually performed after unit testing and is performed by developers. System testing is the process of testing the entire software system to ensure that it meets the requirements and is free of defects. System testing is usually performed by a dedicated testing team. Acceptance testing is the process of testing the software with the end users to ensure that it meets their requirements and is user-friendly. Acceptance testing is usually performed by a dedicated testing team or the end users themselves. There are also several testing techniques, such as black box testing, white box testing, and grey box testing. Black box testing is the process of testing the software without knowledge of its internal workings. White box testing is the process of testing the software with knowledge of its internal workings. Grey box testing is a combination of black box and white box testing. Software testing is a critical process in software engineering, as it ensures that the software is of high quality and meets the requirements. Testing should be performed throughout the software development lifecycle, from the planning phase to the deployment phase. In the final segment, we will discuss software maintenance, which is the process of maintaining software after it has been deployed. Software maintenance is the process of maintaining software after it has been deployed. It involves fixing defects, updating software, and adding new features. There are several types of software maintenance, including corrective maintenance, adaptive maintenance, perfective maintenance, and preventive maintenance. Corrective maintenance is the process of fixing defects in the software. It is usually performed in response to bug reports or user feedback. Adaptive maintenance is the process of modifying the software to adapt to changes in the environment, such as changes in hardware or software platforms. Perfective maintenance is the process of improving the software's performance, usability, or maintainability. It is usually performed to enhance the software's functionality or to make it easier to maintain. Preventive maintenance is the process of proactively maintaining the software to prevent defects from occurring. It includes activities such as code reviews, testing, and refactoring. Software maintenance is a critical process in software engineering, as it ensures that the software remains functional, secure, and up to date. Maintenance should be performed throughout the software's lifecycle, from the planning phase to the retirement phase. In conclusion, software engineering is a complex and challenging field that requires a strong foundation in computer science, mathematics, and programming. It involves the application of engineering principles to software development, with the aim of creating high-quality, reliable, and efficient software systems. By following the software development lifecycle, using the right programming languages and frameworks, performing thorough software testing, and maintaining the software after deployment, software engineers can create software that meets the requirements and is of high quality. Thank you for watching this video on the basics of software engineering. We hope you found it informative and helpful.